we're going to be able to assign some numbers that will identify the location of that electron. So can you tell already that there's more capacity for electrons on the third level than on the second? Electrons are located in orbitals. These are three-dimensional spaces, and we're going to assign some numbers to them. You know how when you get a ticket to a game in a stadium, your ticket may have a level, a section number, and a seat number. And so you know where to go. That's how it is with electrons. We're going to be able to assign some numbers that will identify the location of that electron. So the first one we need to know is N. N is what we call energy level, principal energy level. And N can be 1 through 7. And that actually corresponds with those 7 periods on the periodic table. So that is the lowest energy level is N equals 1. That's closest to the nucleus. The next thing is the sublevel. And these have really strange names. S, P, D, and F. And those letters indicate the type of orbital. Now, an S orbital has a spherical shape. So I'm going to make a sphere there. And then a p orbital has a dumbbell shape. So it might look kind of like that. That would be a p orbital. And then D and F orbitals, there are multiple shapes for those. And I don't really need you to worry about the shapes of D and F orbitals. But these orbitals are three-dimensional spaces, and they have unique shapes. Now, the other thing you need to know is every orbital can hold up to 2 electrons. So that's 1 or 2. Now let's see what's on each level. So if we start with the nucleus, I'm going to write nucleus down here because I like for you to think of, now obviously that's not to scale, but the first energy level is the closest to the nucleus. And so just like in a stadium, that's going to be our smallest level. And then as we go to higher levels, they're going to get larger and larger. So what is on the first level? Well, we have one orbital, and his name is 1s. I'm going to draw a little line there indicating one orbital, and that is N equals 1, and then the type is S. That's it. That's the only orbital on the first level. So let's go to the second level, which is a little farther from the nucleus. We have one s orbital, and his name is 2s. And then we also have some p orbitals, and p orbitals are always in threes. And so I'm going to label those 2p. So there are a total of 4 orbitals on the second level. Now that's it. Let's go to the third level. So on the third level, we have an s orbital, and that would be the 3s. And then we also have p orbitals. They always occur in threes. And then this level is larger. We have d orbitals this time. And so they occur in 5s. So I'm going to draw 5 dashes representing the 5 orbitals. So can you tell already that there's more capacity for electrons on the third level than on the second? You're right. So the fourth level is going to get a little bit larger. So on the fourth level, we've got our s orbital, and then we've got the p orbitals, and then we also have d orbitals. Okay, they're called the 4d orbitals. And then on the fourth level, we have f orbitals, and these always occur in 7s. So that is the 4f orbital. So you can see that is even larger. Now, the 5th, 6th, and 7th levels are just like level 4. They have S, P, D, and F. Are you with me so far? Hang in there. So it's kind of like if we had a hotel scenario, that first number indicates the floor. You know, like if you get your hotel key and your room number is 235, you go to the second floor and look for room number 35. That's kind of what we have here. We've got locations for all of these orbitals. Now, this is the Bohr model, and this is how we talked about the hydrogen spectrum. And if you look at the Bohr model, and he had a pretty good idea of what the atom looked like. N equals 1 would be that first level, and we could put a couple electrons there. And then N equals 2, that second level is a little bit further out. You could stack more electrons in there. And then level 3 and level 4 and so on. I'm not going to draw all of those levels. But can you tell that Small atoms like hydrogen and helium only have electrons in those little low energy levels. But the really large atoms that have maybe 50, 60, 70 electrons, we're going to need to put electrons in these farther orbitals or energy levels. I hope this helps. Keep in mind, this is what you need to know. You need to know what orbitals are on each level. And then the next video, I'm going to show you how to note where the electrons go for every single atom.